Hello everybody, today we're going to be talking about homeostasis. And so homeostasis is the process of the body using energy to make sure that it stays in normal functions. And so we're going to draw a graph to help illustrate this. So here's our graph, and at the bottom we're going to put time, and these are going to be in hours. And we're going to be talking about body temperature. So we're going to put the temperature on the side, body temp. Cool. And so a big point about homeostasis is that there's always a healthy range and a normal range that you want your body to be within. And the most important part about this is the middle, which is the set point. Now the set point is the range in which the variable goes up and down, and it's where the normal range is formed around the set point. Now usually for most of our bodily functions, such as body temperature, we can go a degree or half above and below the set point. So let's show an example of body temperature. So let's say you're working out in a very hot room and you're also exerting a lot of energy. So your body temperature is going to go ahead and increase. So now this increase in this arrow, anytime that your temperature starts to go away from the set point in the middle, this is called a positive feedback loop. And so basically all they do is they go away from the set point and go away towards the edges of the normal zone and could leave the normal zone. And this could be pretty dangerous as our body doesn't function normally when we leave the zone. But thankfully for us, whenever we work out and we get hot, our body is able to go back down again because we sweat. So anytime that you see this loop go down is called a negative feedback loop. And the point of a negative feedback loop is that it brings us back to the set point in the middle and helps us to go away from leaving the normal zone, or if we have left the normal zone, it brings us back into the zone. And so an example of it the other way is that if we are very cold, like if we were outside in Rexburg winter, our body temperature would start to go down. And naturally, our body is very amazing and it's able to go ahead and heat up by shivering. So once again, you can see the positive feedback loop as our body gets cold, and then the negative feedback loop as we begin to shiver and bring our body temperature back to normal. And so that is the first half. Now we're going to be talking about active diffusion and passive diffusion. Now the big difference between active and passive diffusion is that passive diffusion does not have an energy source, while active diffusion has an energy source, and it usually likes using ATP. So now I'm going to show 3 examples of passive diffusion. So the first one is simple diffusion. This one is pretty easy. So let's say this is our cell, and here's our membrane in the middle, and the pluses are our solute. As you can see, on one side I have more concentration of solute, and the other side has less. So during simple diffusion, what happens is that you have little holes in the membrane, and that these are able to go through the membrane to the other side. So some of these pluses would move from the more concentrated to the less concentrated side. And this is the first form of passive diffusion, which is simple diffusion. Now the second one will make another cell. So the second one we're going to talk about is channels for diffusion. So here's our big old cell, and we're going to put a channel in here. Now, the thing about channels is that channels are very useful if you want a large variety of ions to go through, or if you want a lot to go through at one time. Now, these channels, they're not very selective, and they can be very competitive because almost anything can go through a channel. Like let's say we have these different things. They can try to go in and out, and the more powerful one will be able to go through and can push out weaker ones. So, of course, once again, just channels. They don't require any energy source. And as you can see, they're not very selective, and they could have a lot of competition, as maybe some are more powerful than others. Now the other example of this is protein mediated. So while these, you could use an example as like a hole in a building when anything can go in and out, protein mediated is more like a rotating door. So let's say this is our protein mediated, and we'll have our specific protein go in, and once it gets in, the door behind it closes, it's able to go in. Now for these are very good if you want no competition, as these are very specific, and also while they are a lot slower than channels where they can very easily flow in and out. And those are the three types of passive. Now we're going to show the examples of active. So as I said earlier, the difference between active and passive is that active do not require energy sources, passive do not require energy sources, while active do require energy sources. And our first example is let's make our cell one more time, and we'll make this. So this is going to be our example of Na plus K ATP ACE. And so what this does is that it will have 3 NAs get pumped to the outside, and 2 Ks going on the inside. Also, a big difference between active and passive is that passive, it goes with the gradient. However, when it comes to active, the reason why it needs an energy source, which would be right here, this example uses ATP. It needs this energy source of ATP because the potassium and the Na are being pumped against the gradient. And due to this, they need energy or it would not be able to work. And there's also a secondary form of this. This is what is known as the primary form of active. And what it does is that it pumps in and out using ATP. And the other one, it doesn't quite use ATP. What it does is it uses the sodium gradient. And much like the passive one, it is able to pump in and out also against the gradient. And that is all I have to say today. Thank you for listening to Essay 1. 8 minutes.